In this video, we're gonna talk about partial derivatives. The partial derivative will be the most important topic for this chapter, and it's gonna be the foundation for every question. So the partial derivative has the idea similar to the derivative that we have last semester. If you are remembering the calculus one, okay, so for calc one, you have y equal to fx, and you're gonna have the derivative y prime. This guy is gonna be f prime x, and this one is gonna be limit h go to 0 of fx plus h minus fx over h. Okay, so this one will be the definition for the derivative of the function y equal to fx, and that will give you the slope of the tangent line or something that we have last semester. The notation for y prime or f prime x can be written in the fraction way, like you have df dx. Okay, so this one is the notation that we used to use in calculus 1. Okay, so it's going to be df dx that I taught you last semester. df dx. Okay, and for calculus 2, you have z equal to fxy. So for this one, you're gonna be able to find the derivative. It's gonna be two variable. So you're gonna have derivative with respect to x and derivative with respect to y. Okay, so it mean what? It mean that you're gonna have derivative with respect to x when you like to study the change in x. So when you like to study the change in x, you see that you have fx plus h minus fx, kind of the same thing. However, in this case, it turned out to be the function in two variable, and you see that you can measure only the change in the variable x for the partial derivative with respect to x. We not be able to measure the change in x and the change in y at the same time. Okay, so it's kind of difficult to do that. So we're gonna fix y. Okay, so this one is fixed. And we would just study the change in only variable x. And this one will give us the definition of the partial derivative with respect to x. And the notation that we shall use is going to be df dx. So this one has the name, some people call this guy delta. Some people call this guy partial. Some people call this thing the partial of f with respect to x. Okay, some people call this one. However, I'm gonna just say d, so it's gonna be just df dx. So it's gonna be the same. The pronunciation turned out to be the same as this letter d. Okay, so for d for calculus 1, it's gonna be just derivative. However, for d calculus 2, it's gonna be the curly t. The curly d. So it's gonna look like this. Okay, so it's gonna be d, but it's gonna be kind of curly d. So this one, we're gonna read it df dx. Okay, so we're gonna read it df dx or delta f delta x, or some people gonna call this guy partial f partial x. Okay, so it can be read in those way. However, I'm gonna just say d, and my d for calculus 2 will be just the curly d. Or the notation, or another notation that we shall use will be f sub x. So it's going to be f, and we have the subscript x, okay, for that notation. It means that we're going to differentiate with respect to x, and we're going to have y fixed as a constant. So we already take care the variable x. Similarly, we can just find the partial derivative with respect to y. Okay, so this one will be df dy. Okay, so it's going to be df dy, and it's going to be the partial derivative with respect to y. So you have f x y plus k minus f x y over k. And you see that we apply the similar technique here, that you fix x in the second case. Okay, so you fix this x, so you fix this x, and you study the change in y for the second case. And this one, we also use the notation f subscript y for this guy. Okay, so it's gonna be df dx and df dy that we gonna have for partial derivative. So it's gonna be two derivatives, so it's gonna be df dx df dy, and this guy, the notation is fx and fy, and both of them are called partial derivative. This guy always plural. Okay, so this guy always plural, so we always have s. It means that it's going to be two derivatives together when we have the function in two variables. Okay, the way to find this partial derivative will be just using the formula for calculus 1. Okay, so you can just use the formula for calculus 1 in order to find the partial derivative with respect to x and with respect to y. However, when you like to find partial derivative with respect to x, you see y, you see constant, and it's gonna be this one. This is what I wrote here, that when you like to find df dx is the derivative with respect to x when you have y is a constant, and the df dy is the derivative of fx when you have x is a constant. And we can just apply the formula that we have been studying from calculus 1 in order to find partial derivative with respect to x and with respect to y. I will give you some example next. In the next example, you have fxy equal to y squared sine x. Okay, so fxy equal to y squared sine x, and you would want to find the partial derivative with respect to x and with respect to y. Okay, I'm gonna teach you step by step here. So you like to find fx. Fx means you're gonna find derivative ddx with respect to x of y squared sine x. The thing that you have to know is going to be, okay, we like to differentiate this guy with respect to x, and we're going to differentiate only the yellow variable or the yellow function. So for this one, you're gonna just have y squared, so you get this one. So this guy for y squared, okay, y squared here turned out to be constant. Okay, so this guy turned out to be constant, and you gonna just move this guy and you can treat this guy as constant. So the thing that we can do will be, we can just pull the constant outside the parentheses. So it's not outside the parentheses, it's going to be outside the derivative. So it's going to be just y squared. Okay, and you have the dx of sine x. Okay, so that will be the yellow guy. And for this one, you have y squared, and deep side you get cos x. Okay, so deep side you get cos x. And you see that this one result in the first partial derivative with respect to x of this function f. Similarly, you have fy. Fy will be dy. You see the difference turned out to be the variable that turned out to be different, and this one is y squared sine x. and the variable that you are differentiating is y. Okay, so you have x here is a constant, and for this constant you can just move this one outside, so you can just have psi x outside, and you're gonna find dy of y squared. Okay, so this guy will be just the purple term here, and you see that this one gonna be psi x, and you dip y squared, you would get 2y. Okay, so this one is the purple term. So you have fxy equal to y squared psi x, okay? And you're gonna have to find the partial derivative. You have x constant, y constant as usual. So this one will be just the thing that we normally have, okay? And let me conclude some formula for you to use after you see that you see that you need some formula for the thing that we have been studying last semester. This guy is called constant multiple. What is constant multiple? It means that when you like to find derivative, okay, and you have constant multiply with fx, and this c is constant. Okay, so you have this c is a constant. So this will be equal to, okay, the constant, okay, and you have the dx of fx. So this one is the derivative for constant multiple, okay, and this is the thing that we have learned last semester many times, and normally I gonna just teach you in the way that you can just ignore the constant or just copy the constant down, and the serious thing will be you can just differentiate the function in x. Okay, so that will be constant multiple. And another thing that we also learned last semester will be you differentiate constant. Okay, so if you have to differentiate constant, let's just write the full name. Okay, so if I dip constant, when you differentiate constant, it's gonna give you 0. Okay, so it's gonna be, when you dip constant, it's gonna be 0. And when you have calculus 2, constant will be presented in the following way. So, so you can see that if I ask you to differentiate ddx of log y, okay, so let's use partial. So it's going to be ddx of log y. And you see that this guy is a constant. Okay, so this one is y, and this turned out to be constant. Okay, and this one is x. Okay, this one is x. So in this case, when you differentiate ddx of log y, this guy turned out to be 0. Okay, so this guy turned out to be 0. And the reason that this guy turned out to be 0 because y is constant. Okay, so that is going to be kind of tricky for calculus 2. And when you have the dy of tan x to the third, something like this, okay? So this one, again, the variable that you have here is x, and the derivative that you are finding turn out to be with respect to y. So for x here, this guy is a constant, and you have x is a constant, tan x is a tan of constant, so it's going to be constant, and you have raised to the third power, it's also become constant. So in this case, you get also 0. Okay, so you see that you have to take a look at the variable that you are differentiating, and if it turns out to be constant, it's going to be using constant multiple or dip constant is equal to 0. So if you get this idea, you should be fine after this lecture. Okay, so this lecture, the confusing turned out to be just when to use constant multiple or how to indicate the constant that we have. Okay, let's try to do this one. So you have fxy equal to root x plus 2 log y. So for this one, if you like to find fx, so it's going to be d dx of root x plus 2 log y. Okay, and you can just differentiate this guy and you can just differentiate this guy. So you're gonna differentiate root x, so it's gonna be 1 over 2 root x like we did last semester, and we have d dx of log y, so you are differentiating with respect to x. Okay, and you see that it's going to be x here that we already done. So you're gonna differentiate 2 log y. So log y here turn out to be constant. Okay, so you're gonna get 0. Okay, so this one will turn out to be hard to write down. Hey, deep log is going to be 1 over y. No, it's not going to be 1 over y. It's going to be 0 because you are differentiating with respect to x. Okay, so you have to be able to distinguish between x and y for this topic. The second one will be you like to find fy. Okay, so I'm gonna do slowly. So it's gonna be d dy, and for this one it's gonna be root x plus 2 log y. Again, you see this one that is gonna be derivative with respect to y, and they have y here for the second term, and for root x this guy is a constant. Okay, and you dip constant, the first guy turn out to give you 0, the second guy will be dip log y, and this is the thing that you answered me before. So it's going to be dip log y is going to be 1 over y. Okay, and it's going to become 2 over y for final answer, and this guy will become 1 over 2 root x for final answer. After this lecture, I would want you to be able to go from here to here automatically. We're not gonna do step by step anymore. Okay, so I do step by step only for this example that I like you to see the distinction between constant multiple and the derivative of constant equal to 0. After this one, I would like you to just answer it. Okay, so you just answer it one line, so it's going to be fast and it's going to be the common thing to do after this lecture. Okay, so I'm gonna begin showing you example 10. Okay, in example 10, you see that the thing that we're gonna do is gonna be, we're gonna find partial derivative, and like I mentioned earlier, this one always plural. Okay, so you're gonna have to find derivative with respect to x and derivative with respect to y, and you see that it's gonna be sum of two functions like this. So it's gonna be just, you're gonna find fx. Okay, so you're gonna find derivative with respect to x of the whole thing, root y e to the y plus r tan x minus 2 pi, and you see that you have function in terms of x, and this one will be first thing, this one will be the second thing, and you're gonna indicate that this guy are constant and 2 pi also constant. So the derivative that we will have will be just, you see that you have y here is also constant. okay? So you see that it's gonna be constant multiple, and you're gonna dip x cubed, so it's gonna be 3x squared. So this one is the yellow guy, okay? Let me do it in a correct way. So for this one, I'm gonna highlight only, I'm gonna highlight only x. So it's going to be just x cubed. And you see that I just pull out the square root y, and I gonna just differentiate 3x squared. Okay, so for that guy, let me change this one to the correct color also. So it's gonna be 3x squared. Okay, and this one is 3x squared. And you dip e to the y, you get 0. Okay, so it's going to be minus 0. Minus or plus, it doesn't matter. It's going to give you nothing anyway. So you have arctan x, so it's going to be 1 over 1 plus x squared. Okay, and the last thing is 2 pi, so you get 2 pi, so it's going to be 0. Okay, so that is going to be your fx. Okay, so that's your final answer. So normally we gonna just erase this 0 and this 0, so we can just erase these two, and you just have 2 terms for final answer. And most of the time, I'm gonna go from here to here automatically. Okay, so that's my fx. So I would want you to do fy on your own first. Okay, so it's going to be the same thing, x to the third square root y minus e to the y plus arctan x minus 2 pi, and try to follow fx, and you should be able to do fy on your own. Okay, so this one is 2 terms in terms of y. Okay, I let you do this one first. The next one, you have fx y equal to e to the x sine y. So for this one, it's gonna be, you need fx. Okay, so you need fx. So it's gonna be d dx of e to the x times sine y. Okay, and this one is derivative of e to the u. Okay, derivative of e to the u, the dx of e to the u. So this one equal to e to the u times u prime. Okay, so that is going to be the thing that we used to do last semester. So for this one, it's going to be derivative. Okay, so it's going to be e to the u, and you have derivative with respect to x of x sine y. Okay, so that will be the thing that we have. And you see that we have derivative of x sine y. So you're gonna just pull out sine y to the front, and the thing that you would get will be e to the x sine y times sine y, okay, times sine y, and you find derivative with respect to x of x, so it's going to give you 1. Okay, so that's my yellow term. Okay, so that's my yellow term. So that will be my final answer. Okay, so d dx of x is equal to 1. For the partial derivative with respect to y, so it's going to be d dy of e to the x sine y. And this one again is going to be e to the x sine y. Okay, and you have d dy of x sine y. The thing that I'd like you to notice will be, you see that this one is the derivative with respect to y instead of x before. So the difference turned out to be here. You see the color here. The first one is derivative with respect to x. The second one is derivative with respect to y. Like I told you earlier, that you must be able to distinguish among derivative with respect to x and derivative with respect to y. Okay. So for this one, it's gonna be e to the x sine y, and you're gonna pull out the constant x to the front. Okay, so you pull out constant x to the front, and you're gonna find derivative of sine. Derivative of sine will be cos y. Okay, so this one will be the yellow one that you have. Sorry, the purple one that you have. Okay, so that will be the correct answer for this one. So you see some different here. So that one, you multiply by 1. Okay, so you multiply by 1. And here you multiply by x, okay, from this term. And this side is cosine. Okay, so that is going to be just the formula that we have been studying last semester as well. Okay, so that my fx and fy. For the third one, you have fxy equal to the cubic root of x plus y to the third raised to the fourth. So for this one, you're gonna just have fx equal to 4 the cubic root of x plus y to the third. Okay, and you have to the, sorry, I have to be slow. I have to warn myself. This one is your first one. So it's going to be d dx of the cubic root of x plus y to the third to the fourth. And this one is the derivative of u to the n. Okay, so if you like to find derivative of u to the n, last semester it's going to be n u to the n minus 1 du dx. Okay, so it's going to be d dx of u to the n. So it's going to be n u to the n minus 1 du dx. So for this one, it's going to be 4 down, and it's going to be the cubic root of x plus y to the third to the 4 minus 1, and you find derivative d dx of the cubic root of x plus y to the third. Okay, and you see that this one you are differentiating with respect to x. Okay, so you are differentiating with respect to x. So this is just you're gonna find derivative with respect to x. So you dip this guy and you dip this guy. So you dip the cubic root of x. So it's gonna be 1/3 x to the negative 2/3. Okay, so for that term. And you see the second term is going to be plus y to the third, so it's going to be plus 0. Okay, so dip y to the third is going to be plus 0. So this one will be for the cubic root of x plus y to the third, and you dip x to the 1/3, so it's going to be 1/3 x to the negative 2/3, and you differentiate y cubed, you get 0. Okay, so that will be that my fx. Okay, I'd like you to try fy on your own. I'm not gonna help you anything at all. Okay, so for this one, I just want you to try on your own to be to see whether you understand this one. Okay, so that is gonna be for fx and fy. The next one, you have fxy equal to x squared tan x plus 2y. So the thing that we're gonna do is gonna be, we're gonna find the derivative with respect to x and with respect to y, fx. So it's gonna be d dx of x squared times tan x plus 2y. and you see that you are differentiating with respect to x, and you have x for the first function and x for the second function, and this one turned out to be product. Okay, so it's turned out to be product between two functions in terms of x. So for this one, it's gonna be, you need to use the product rule. Okay, so you will need to use the product rule, and the product rule will give you in terms of the first derivative of the second plus the second derivative of the first. Okay, so you have the first derivative of the second plus the second derivative of the first. So that is going to be the term in terms of x. And you would just have, okay, so you would just have x squared, and you dip tan x plus 2y. So it's going to be secant square x plus 2y. Okay, so dip tan is sec square, and you see that you have to differentiate the inside. So you have to dx. So this one is going to be d of x plus 2y. Okay, so that will be derivative of the inside. Okay, so it's gonna be the first guy. The second guy will be, you have tan of x plus 2y, and you have the x dx here, d dx of x squared, so it's gonna become 2x. Okay, so that is gonna be 2x. Yeah, so it's gonna be this product. And you see that it's going to be x squared secant square x plus 2y, and you dip x plus 2y is going to be 1. Okay, so that is going to be, let's write everything 1 plus 0. So you see, and for the second one, it's going to be tan x plus 2y multiplied with 2x. Okay, so that will be just that. The next one, you like to find Fy. For Fy, you're gonna set this one up. So it's gonna be d dy, and you differentiate with respect to y of x squared tan x plus 2y. You see that this one you are differentiating with respect to y, okay? And you have y for the second function only. For the first one, this guy become constant. Okay, so this guy become constant. So this one is not product. Okay, so this one is not product. It's constant multiple. Okay, so it's constant multiple, it's not product. So for this one, you allow to just pull out the constant. So it's going to be x squared, and you have d dy of tan x plus 2y. Okay, and you have derivative. Okay, so x squared is x squared, copy down. Derivative of tan is secant square x plus 2y, and you have the dy of x plus 2y. Okay, and you see that this is the derivative of the thing that inside, like we have last semester by using the chain rule. And finally, we would just have x squared secant square x plus 2y, and you have derivative of x with respect to y. Again, this guy is constant, so it would give you 0, and it's gonna be 2. Okay, so that's how we have the partial derivative with respect to x and with respect to y. Okay, so that is going to be fx and fy. For number 5, okay, number 5 here, you would apply the quotient rule. So you see that for this one, for d dx, okay, for fx, so this one is going to be d dx, and it's going to be x plus log y over root y. Okay, so for this one it's going to be, you see that you are differentiating with respect to x, and you have x only, the function on top, and you have root y become constant. Okay, so we have root y become constant. So this one again, constant multiple. So you're gonna just have 1 over root y, okay, by just pulling this guy outside, and you end up with the dx of x plus log y. Okay, so this one is gonna be just constant multiple. Okay. And so you're gonna just differentiate this x plus log y. I let you finish this one. It's gonna be just one line, so I gonna differentiate for you. So you have d dx of x plus log y, so it's gonna be 1 plus 0. Okay, so this one become constant. And you just differentiate the yellow guy, so it's gonna give me just 0. The last one for fy is gonna be d dx. Okay, so it's gonna be d dx of d dy. It's gonna be d dy, and d dy of x plus log y over root y. And you see that for this one, you have d dy, and you have y on the bottom, and you have y on top. So this one is going to be quotient between two functions. Okay, so it's going to turn out to be quotient between two functions in terms of y. So you use the quotient rule. Okay, so you just use the quotient rule, so it's going to be the bottom derivative of the top minus the top. The top is x plus log y, derivative of the bottom, d dy of root y, okay, over the bottom square. Okay, so it's going to be the bottom derivative of the top minus the top derivative of the bottom over the bottom square. And this one will be root y. And you have d dy of x plus log y. So for this guy, it's going to be 0. Okay, and you dip log y, you get 1 over y. So this one will be 0 plus 1 over y minus x plus log y. Okay, and you dip root y, it's going to be 1 over 2 root y, and it's going to be over y. Okay, because square root y square is turned out to be y. okay? And this one, if you simplify this one a little bit, root y and y, so it's gonna be 1 over root y, and you're gonna just have x plus log y over 2 root y, and everything turned out to be times 1 over y for final answer. Okay, so that is gonna be all of the thing that I like to teach you for this lecture. Okay, we're gonna continue number 6, number 7 together with the higher order partial derivative next time. Okay, for today it's gonna be just a small preparation for you to be able to do like a partial derivative. Okay, try to do the thing that I left you on your own. Okay, you should be able to understand this topic, and this topic will be the most important one for this chapter. Okay, this chapter has the name partial derivative, and this guy is the leading, so this one is play the leading role for this chapter. Okay, so that would be all of this clip.